Let us see some of the properties of supercritical fluids. Supercritical fluids differ from their counterparts such as the gaseous phase and liquid phase with respect to three important properties, which are density in gram per centimeter cube, diffusion coefficient in centimeter square per second, and viscosity in gram per centimeter per second. So here you can see that there is a significant difference in the density between the three phases, that is gaseous phase, supercritical fluid phase and the liquid phase. Also there is significant difference in the diffusion coefficient and in the viscosity for the three different phases of a substance. There are dozens of the supercritical fluids which are used in supercritical fluid chromatography as well as SFE, that is supercritical fluid extraction. But the most commonly used supercritical fluids for supercritical fluid chromatography are carbon dioxide, nitric oxide, ammonia, and N-butane. The critical temperature for these substances is in the range of 31.3 to 152 degrees Celsius. So for if you consider the CO2, the critical temperature for CO2 is 31.3 degrees Celsius and critical pressure is 72.9 atmosphere. These conditions are quite controllable. These conditions are similar to those which we generally use in the HPLC. Same is the case for nitric oxide. So they have the critical temperature and pressures well within the range of control, and therefore they can be easily used for the chromatographic purpose. So a supercritical fluid is able to dissolve large non-volatile molecules. This is due to their high densities. So they have high densities in the range of 0.2 to 0.5 gram per centimeter square per centimeter cube. So because of this high density, they are able to dissolve large non-volatile molecules. Supercritical carbon dioxide readily dissolves the N-alkane containing 5 to 22 carbon atoms. They can dissolve di-N-alkyl phthalate, in which the alkyl groups contain 4 to 16 carbon atoms, and they can also dissolve various polycyclic aromatic hydrocarbons consisting of several rings. So three different types of molecules or substances can be dissolved by the carbon dioxide. Besides that, supercritical fluid has been employed for extracting caffeine from coffee beans to give decaffeinated coffee and extracting nicotine from cigarette tobacco. So supercritical fluids, since they can dissolve different types of the substances, they can be used for extracting the caffeine from coffee beans and nicotine from the cigarette tobacco. The analytes dissolved in them can be easily recovered by simply allowing the solution to equilibrate with the atmosphere at relatively low temperatures. So thus, an analyte dissolved in supercritical carbon dioxide can be recovered by simply reducing the pressure and allowing the fluid to evaporate under ambient laboratory conditions. So just by reducing the pressure, we can evaporate the carbon dioxide and we can extract or we can isolate the material. This property is particularly important with thermally unstable analytes. We know that the thermally unstable analytes cannot be extracted at high temperature. So supercritical fluid gives us a good option for isolating such type of material. Okay, so these are the properties of supercritical fluid that you need to remember. The properties related to dissolution of large